Cool. Hi. I hope you're all enjoying GeeCON. It's the end of the second day. I know everyone is tired and shagged out, so thank you very much for coming. I will try my best to entertain and not bore you for the next 15, 20 minutes. And just for context, I've been using Scala professionally since 2011. And unfortunately, not as much for the last few years since I quit the company that I used to work for, which you may have heard of, called Wix. Wix is heavily a Scala shop, so that's where I did most of my Scala work. Since then, I've been actually mostly freelancing. I've had the opportunity to learn and employ professionally a bunch of languages, including, unfortunately, Python. But I feel that this period of a few years of not using Scala actually led me to reflect and think of how my approach to software engineering has been shaped by using Scala professionally for a few years. And there's a few kind of core things that I feel Scala has taught me as a software engineer. And I'm very curious to know if anyone else has shared this experience or has a different perspective that maybe they want to share. So I'd be happy to debate any of this or argue about any of this later on or in the questions. Please feel free. So without further ado, what has Scala taught me about software engineering? Well, the first thing Scala has taught me about software engineering is that declarative programming, or what's sometimes called functional style programming, is actually tremendously useful. So here we have a very stupid piece of code. It's just a function, takes in a list of people, filters out all of the people that, whose age is 18 or above, and spits out a list of those people. So basically just the adults in the group. Now, the nice thing that Scala taught me right out the gate is, and this is, I think, something we've finally learned as an industry, is that this type of coding, this isn't functional style, by the way, this is very imperative, old school Java. This style of programming is focusing on the wrong thing. It's focusing on the how to accomplish a task. How to, which data structure, intermediate data structure should I use? Should it be an array list or linked list or some other type of thing? It focuses on the wrong thing. Scala taught me to focus on the what. And this is the exact same code, except listed as in using Java streams, Java collections and Java streams. And it is so much more readable. It focuses on what it is I'm trying to accomplish. It's a lot more concise, a lot more terse, and that's a good thing. So the first thing that Scala taught me about software engineering is always focus on what it is I'm trying to accomplish and not the how of accomplishing it. That is a very powerful idea, because focusing on what you're trying to accomplish is always the better thing to do. It reduces complexity, especially accidental complexity, and it decouples your intent as a software engineer from how the code actually does what it does, which ironically is not the thing you care about most of the time. And that also means that the underlying framework, the collection framework, whatever it is you're working on top of, has the opportunity to optimize things. If you declare what it is you're trying to accomplish, people who are not necessarily smarter than you, but definitely more specialized than you, can actually do a lot of under the behind the scenes work to get your code to run faster, better, safer, etc., etc. So that is the first lesson. It's a trivial one, but an important one. The second thing that Scala taught me about software engineering is that everything you can do in build time is always better than doing the same thing at runtime. Or in other words, reflection is evil. We all know the sort of issues that you come across when you use reflection-based libraries, because let's face it, a lot of the libraries we end up using in the Java space are reflection-based. So just 3 canonical examples: Spring, Jackson, Hibernate. All of these are reflection-based libraries, and if you use them, and probably a lot of you do, you're paying a very, very heavy price for the convenience that they afford you. You pay in increased complexity, increased startup time, increased memory use. You get severe limitations. So for instance, a lot of you have probably have had the wonderful experience of trying to get Jackson to serialize or deserialize generic types of any sort, generic collections, or anything of that nature. More importantly, though, things break really, really easily, and you're only going to know about it in runtime. The only way to avoid the sort of annoying, gnarly issues, especially with Hibernate, unfortunately, the only way to avoid these issues is to write and run tests. And these are tests that you should not need to write because your code already expresses your intent. The fact that you need to write a test to validate that these libraries reason in runtime through reflection about your classes, your annotations, your whatnot, is just accidental complexity, and you end up paying all of those prices. You end up dealing with a lot of completely accidental issues like type erasure, security manager related issues with reflection, weird class loading issues. A lot of these problems just should not exist in your problem domain. Scala offers several non-runtime solutions to these problems. So the canonical way of approaching this would be do things at compile time or at build time, right? Have some sort of code generation plugin built into your build pipeline. So some canonical example of this would be Lombok or gRPC. These are better solutions. They're not particularly lovely solutions, but they are better because you're going to know ahead of time when things break. And you're going to have the opportunity to observe what these libraries do before the code actually breaks at runtime. But Scala also adds two solutions to the mix that unfortunately don't really have a mental equivalent in today's Java space, which is metaprogramming, in other words, Scala macros, and type classes, which is an amazing type level feature that doesn't really exist in most languages today, with some exceptions. And unfortunately, there's nothing like that in Java. So what Scala taught me is that anything you can do at build time instead of at runtime is going to be great for you, is going to save you a world of pain. The third thing that Scala taught me is that strong typing is super important. Now, for those of you who have been to Anjay's talk, I think it was earlier today or maybe late yesterday, he made the case that static typing kind of basically won. I would agree with that. When it comes to large systems, static typing has won. Most languages that you would use to build large systems in today offer some sort of strong static type system on top of whatever it is that they were originally designed to do. And it turns out that strong static typing actually matters a lot. It gives you expressiveness. It lets you discover things as you type, right? You get proper auto-completion. You know what it is you can do in any particular context within your code. It also affords predictability and performance, and it gives you tooling support. So a strong type system is an incredible thing to have, and I don't think I realized just how much until I started developing in Scala. Now, the interesting thing is that this isn't specifically about Scala, and this isn't specifically about me, because if you look at the evolution of Java, it appears that Scala has taught all of us the importance of a strong and expressive type system. So that is why I think Scala is kind of directly responsible for influencing the evolution of the Java language all the way back to Java 8 with lambdas and streams and adding various collection classes and optionals. But that was years and years ago. Since then, we have gained in Java, we've gained type inference, two types of type inference actually. We've gained switch. The switch statement from back in the day has evolved tremendously to not only allow you some limited forms of pattern matching and type checks, but it also became an expression rather than a statement, which also affords a lot of power to Java developers today. You will have noticed that Java has gained sealed interfaces and classes, which were covered in a number of talks in this conference. And that is an incredibly powerful and expressive mechanism because it lets you do things safely in a way that you can later refactor, that you can reason about. You get real error message. The compiler protects you. So the value of strong typing, I feel I've learned a lot from Scala about the value of strong typing, and I think it has significantly influenced the evolution of commonplace language idioms today, including in Java itself. So, with all of the above, really the key things I think we can take from Scala is that expressiveness leads to efficiency. The things that Scala lets you do, and nowadays Java is starting to let you accomplish as well with features like sealed interfaces, sealed classes, and switch statements, all of these lead to efficiency. You can write code in Scala very, very efficiently. The code is dense, but it is also very expressive. It can do a lot, and you can write it very, very quickly and safely. So expressiveness leads to efficiency. That is, I think, a key takeaway from several years of working with Scala. And whenever I find myself working in a different tech stack, I miss that expressiveness. Even with modern Java, there's a lot of features that are missing that I feel would have made me a much more efficient software engineer, like type classes. If I have to work in Python, let's not even go there. The other takeaway is that safety leads to effectiveness as opposed to efficiency. Efficiency is about being able to build stuff quickly and safely. But the inherent safety of a strong type system, the inherent safety of doing stuff at build time and compile time as opposed to runtime, actually means you're a more effective software engineer. You avoid classes of bugs. You can refactor a lot more quickly and a lot more safely. You don't need to write ridiculous type-based tests just to make sure that your Jackson annotations don't muck up your serialization. It makes you a much more effective software engineer. And finally, I think that Scala really has taught all of us, right? You can trace the lineage of a lot of what's been going on in languages over the last 10 years to the dramatic spike in popularity of Scala, which admittedly did not cause Scala to become a mainstream language. It never kind of crossed that chasm, but it has influenced a lot of the languages that the language features and the languages that we look at today as sort of mainstream useful languages. Kotlin can be thought of as a lighter weight Scala. And I think even many Kotlin engineers would admit that Scala was both a positive and a negative influence on what to do or not do in the design of Kotlin. Java is making huge strides and adding more and more features that make it seem more and more kind of Scala-esque in many ways. TypeScript, I think, owes a lot to Scala for popularizing certain types of type system features. Even Python is getting types, right? Python, as a core language feature, is getting heavier and heavier static typing features in the language in and of itself. And finally, just one example that isn't mentioned here, Rust. I think Rust has learned many, many lessons from Scala, and Rust would not be the language that it is today were it not for a lot of features that Scala kind of popularized and made mainstream. So, in short, expressiveness, type safety gets you better software. And I feel that working in Scala for a few years has made the code that I write today in any language considerably more idiomatic, functional style. I tend towards immutability when I can. There's a lot of little things that I take for granted today that I'm not sure I would have internalized were it not for several years of working in Scala. So, do I love Scala? Yes. Would I want to be able to continue working in Scala, despite the language not being the hyper mainstream Java replacement that some of us were hoping it would have been like 10 or even 5 years ago? Definitely. I miss it dearly. But it has taught me a lot, and I'm very grateful for the time I spent in that ecosystem. And if you haven't already kind of given it a look or tried it out, I would recommend doing that, even if it's not practical for your day job, because you actually stand to learn a lot from what Scala has to offer. And with that, this lightning talk and the last slot of the day is done. If there are any questions, I'd be happy to take them. And thank you very much for attending GeeCON. Have a good day.